Oh, hi guys and girls, Emma again. Welcome back to the Patreon series. This little traction engine. It's starting to come together nicely. Last time we made the burner, and we've made the safety valve. The time before that we made this frame, which is just a little bit of tin or a bit of brass that's folded up, and the crankshaft runs through here. Now we've made a start on the crankshaft, and it's got a taper on one end and it's just cut to length. It's a pretty basic piece. Next thing really, I think, is to make the crank disc. Now a bit bigger is probably a bit better than a bit smaller. And if we have a look, that's what we've got, which is basically a flywheel or a crank. It's got an offset hole with a crank pin that's been, it's got quite an ingenious method of fitting it all together. It's all pressed together on tapers or so forth. It's a really well made, well designed thing, and it's fairly easy to make reasonable results. It's got a recess in the front here, which is for some paint, just a stripe, and we've decided on green to paint that, and we're going to paint that before we really this part's going to be painted and it's half constructed. So we've gone with green. I'm probably going to leave what shaded green to my discretion, so we're going to have a look at that. I've got some green there. That's not a very difficult thing. It says we need a piece of 38 or 35 inch and a half diameter BDMS, which is kind of all over the place. That call out's pretty vague really. 35 or 38 or inch and a half. Inch and a half is about 38, 37 and a half, 38. 35's probably plenty big enough. If you've got something that's 35, or if you've got something that won't quite clean up, that'll do. Bright drawn mild steel is probably the best thing for it. I've had a look at some offcuts here. I've got a piece of something that says it's D21 46 millimeters. No idea, it looks like my handwriting, so it could be that, whatever it is. I think that's what I made the original one out of, or the one off my stationary engine. I've got a piece of aluminium, which would do nicely. It really wouldn't be too shabby. That'd do fine if that's all you had. Got a piece of cast iron, and that'd do fine too. I've got a short offcut that'd probably clean up to 9 millimeter, and that's probably a smart thing to use as well. It's not going to polish nice, and it's going to go rusty quick, and it's probably not going to stay on real tight on the shaft, so I'm not going to use that. There's a bit of brass there that'd be plenty good enough. That'd look good too. And if that was something that made your clock tick, well, you could use that and it wouldn't be too shabby at all. But I might keep that for something else. So out of these two bits of stuff, I look like I've turned that and got some reasonable results with it. So that's one thing for that. This wouldn't take a lot of machining either. However, it's probably hardly got the weight in it to make the thing run smooth, so we might leave that as well. And that leaves us with this. It's about 40 millimeters. That's cleaned up too. So the secret, I guess, will be to dial this in and machine it down to diameter on the edge. So I'm going to set this up in the 4-jaw chuck because it's about the only chuck I've got that I think is going to hold this. I don't think my 3-jaw is going to hold it. And face this and surface the outside, and then part him off, turn him round and face the outside and put the fin in it, and then we're going to drill the crank pin and kind of call it done. So in the end, what you really want is a slug of metal that's 38mm diameter and about 11, 10, something like that millimeters thick. Right? What I've done is trued that up in the lathe and parted it off. This isn't the answer for everyone. A bigger lathe than mine should manage it okay. A lot of people who are beginning lathe work will really struggle to part off a piece of 40mm steel. That's hard work. The sensible thing, of course, to do is when you order this, and order it on eBay or order it from your supplier, or buy an offcut somewhere, or go in and give someone a carton of beer and dig around in the scrap drawer and see what you can find. But don't be afraid to ask to get them to cut it off. If they've got a nice power hacksaw, you'll get nice clean square slugs which will save you hours of time, either with a handsaw or with your own crappy power hacksaw or with a part off tool or with a 4-inch grinder or whatever you're going to do to cut it off. Spend the $8 carton charge or call in a favour or whatever and get someone to chop it off. That's sort of a fairly, that's a good place to start. This will go on here, something like this, which will make it look a lot more like a traction engine. Next job when that cools down is to set it up in the 3-jaw, probably with a spacer. And find something that's smaller diameter than that and bigger diameter than the hole in the middle of your 3-jaw, and set it up so that it's nice and parallel. A good thing to use probably is a bearing journal, an old bearing journal like this. If you have an old wheel bearing journal like that, that's appropriate size. This isn't. It's much too small for this one. But just to give you an idea, that's probably a really good spacer for something like that. It's nice and accurate. Piece of high-speed steel to set it up on is probably as good as anything. All we need to do is set it up in the 3-jaw repeatedly so it doesn't wobble, so we can machine this face and this face. So we'll dig around and look for something to set this up on and let this cool off a little bit, and then it's time to set him up and to face this side. So what we need is a disc that looks like this. This is 38mm diameter and it's 9mm thick. Now, you can just measure that with a vernier. However, you can't get that vernier in there to measure nice and square, so you're going to end up with an error. There's a couple of ways you could do this. If you set this up on a piece of high-speed steel like this, which you probably did, then you can use the vernier that way to measure accurately using the depth gauge. You could also use a depth mic, or you could use a uni mic which has only one anvil, which will sit down there nicely and give you an accurate reading there. Bear in mind, if you use a depth mic, that a lot of them read back to front, so that can be a little bit confusing. But you only need 9mm, and a ruler here with a stop on it will be plenty good enough if you've got a good sense of feel. This is probably a fraction big, but you should be able to get some sort of a feel of how big that is and get it somewhere near accurate. Certainly accurate enough to do the job. So when you're done, and this side's been faced and the outside should be nice and true, and this side's been faced, the next job's a hole in the middle. If we call this the back, then this taper needs to seat nicely in the hole. How do we do that? Well, if we have a look here, it's not really a taper. It says we center drill it, then we drill 3.8 all the way through, and we counterbore 4 diameter, or the diameter of your crank, 7 deep. So that's what we need to do. When we center drill it, we don't want it to be we don't want the center part to be bigger than 3.8 millimeters. But we want to use the biggest center drill that we've got for a couple of reasons. A smaller drill's gonna wander a bit if your tool wasn't quite on center, and it's probably going to break. And a big solid drill like that is just going to give you a nice true hole. And you drill that right through 3.8 millimeters. And we need to counterbore it. So there's a couple of ways we can do this. Look, my center, or my tailstock has a very accurate scale here. That's a good way to start. The other thing you can do probably is clamp something on here and measure it. If you have a clamp for here, if you have, say, something that's a good fit, you could also find a gauge block if you're that way inclined, or just a piece of stock that goes between the back of your chuck and here, and set that as 0 and find another piece of stock the right thickness to, and drill it till it just falls in there. That's a good way. Another thing you could do, which isn't particularly successful but works, is to put either a piece of tube on here and measure back the distance you want to go, or put a piece of tape on it and measure the distance. This should then grip nicely on there. It should be a good push fit in there. Grip nicely on there, a bit of Loctite on there if you need to, and you should have that running pretty true. One tap with a hammer. Because this is the side that's been opened up, it's also the inside of the flywheel. Make sure there's no burr on there. We've got rid of that. I'm going to turn this around and we're going to put a groove in the front. Have a bit of a look at how we're going to do that. Now we need to have a talk about parallels while we're setting this up. High-speed steels quite often the same size. So if you need two of them, just check with a micrometer and find out which side and mark it, right? Because sometimes, while it's parallel and nice, it's not always the same size both ways. So just be aware of that. And if you're going to use high-speed steel or two pieces of high-speed steel as a parallel, be aware that it may not be the same both ways. So using a 60-degree tool, or whatever you've got, something with, turn it round square and machine a chamfer in here. That's pretty easy. It's only cosmetic. What you do need to be careful of though is that this crank pin is 8mm from the centre to centre. So it's 3mm, so you've got about 9.5 or 10mm to the outside from the centre. So you don't want this groove to go over the top of your crank pin. We're just going to drill that in, and it's a fairly straightforward sort of an operation. But all I'm concerned about tonight, and the reason I'm still doing this at this sort of time, is that I want to paint this stripe, and then when the paint's dry I can just polish the top of it off without disturbing it, and we can finish it. And we can have a nice, neat, tidy stripe. So let's find some paint. So I was put a poll up on Patreon to see what colour, and green was the outstanding vote. Not sure why. This little engine will look as nice in anything. In fact, Kenneth Wells himself did his in yellow. And that's okay. Green's not bad. I haven't got a green engine, so I did reserve the right to pick what colour green. So I've picked medium green, which is a one-shot colour. I've got a tin of it that probably needs using up before it goes hard. And I've just painted this groove that we cut in here all round there and let it dry overnight. Now I'm going to take a skim cut off the top just to polish it up. And we've got a nice green circle around there, which is what we wanted, and give it a bit of a polish up on the outside. So that's our disc. We've got the crank, which actually fits in from this direction. It should go nearly all the way in. Good tap there will seat that nicely so that it's tight. Maybe a little bit of Loctite on it. It should run pretty true without too much effort, really. Last job's to put a crank pin in here. So the easiest way to do that is to use a centre finder and a scriber, and I'm just going to run across there like that. This needs to be 8mm from the centre, and rather than try and plug this or try and find the centre, probably the easiest way, pick up the verniers and work out what this diameter actually is, and it's 39mm. Half of that is 19.5mm is the centre. Less 8 is 11.5. rather than blue that up and have to wash it off afterwards and then end up washing all the paint off the other side, etc, 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 I'm just going to put a Sharpie mark on there. So when that's marked, we should be 8mm from the centre there, and all we need to do is drill that through 3mm or 1/8 or whatever piece of silver steel you've got. I think I've got plenty of 1/8, so we might just use that. So I'll drill in 1/8, probably 3mm and then 1/8, and we'll have a look at fitting a crank pin. So when that's drilled through, and you want it fairly accurate on size, so if you're a bit concerned about a hole cutting oversize, drill it with a new drill a fraction under. So I've drilled it 3.3mm and then I've drilled it out to 1/8, which is 3.2 roughly. I've got a piece of 1/8 silver steel or drill rod, and I've cleaned the ends of it up easy. And that fits in there like that. We don't put that together yet. First job really is to put this on and make sure it does fit nice. Let's set him up in the lathe and check for run out. We can give him a tap and we can take a bit off there if we need to, if we've got too much taper. And I think that's sticking out there on the end. I might just do that. So we'll shorten that up. I'm going to just sit that on there in the lathe. I'll put this in a collet and I'll just set this on the lathe. And I'll see how this runs. See if it's nice and true or if it's anywhere near true. We might have to run the cross slide across and just clean that up again. But I don't think it's going to be far out. So I've set that up. That runs pretty nice there. If we have a look, there's no pip in the centre. In fact, it's down a little bit, and when I press that on, that's going to probably be a fraction proud. I might just take a fraction more off it. You can see the line where the step has come up to, and that's about halfway along the taper. That's where it wants to be. I'm going to take a little bit more off there, maybe. I think that'll be alright. And we'll put him together. This is a fairly straightforward little job. This needs a hit with a hammer on one side, just a tap to flatten it a little bit. A nice hard hammer on the anvil. So I'm just going to give that a tap. That's all that needs. And that won't quite go in there, but it will press together, so pretty happy about that. This will press together too and it won't come apart. However, I'm going to cheat because a little bit of insurance is sometimes a good thing. That's not coming apart. This one, that's going to need a hole in a bench block or something to tap that in fairly quickly. Probably just over the jaws of the vise. I've given that a tap just with a pin punch on the vise. I'll tap that home nicely. And if we have a good look at that, that should be nice and square there and nice and square there. And that's the first part of the engine painted and the crank on. Really pleased with that. Thanks for watching. That's probably going to do me for tonight. It's Wednesday night. Oh, it's Tuesday night, I think. I think we've got a live stream tomorrow night. If anyone wants to tune in, it's early American time. It's about 8 p.m. Australian time. We usually chat for about half hour, something like that. That's Wednesday nights usually on my channel, so head over there if you're interested. Otherwise, thanks for watching. Be kind to each other. Big shout out to everyone who puts in a little bit to watch these videos, and more soon.